Hello, today we're coming to you with a widescreen version of the PowerPoint presentation, hoping that this will resolve some of the formatting issues that I get from going from PC to Mac when I record these videos, but we'll find out soon enough. All right, we're doing the Canli study, and if you don't remember what that is, that's about amygdala activation in correlation with high arousal images or just images in general. And we'll see if high arousal leads to higher amygdala activation, specifically the left amygdala. And we'll talk about that later. First, we talked about our earliest childhood memories and how, unsurprisingly, we tend to remember things that are highly arousing, maybe some danger, maybe a car accident, but the more mundane things are usually not as easily remembered. And that's really an oversimplification of the study. It was pretty much doing the same kind of thing. Instead of using anecdotal, though, we're using actual hard science, things like FMRI machines and this IAPS, which is the International Effective Picture System. There are 96 images that were used to evoke a response, some sort of emotional response from the participants. Before we get into any of this, actually, I should probably stop by going over the brain parts that are relevant to this study. The key brain parts to know essentially is just one, the amygdala. Easy peasy. This is a big, massive, complex organ, but we're just looking at the amygdala, which is good because you could study like AP style every part of the brain and forget about it a week later. Here, I really want you to know this one part, and that's about it for the rest of the year. The amygdala is associated with strong emotions such as fear. It's associated with memories that are traumatic, and it initiates the fight or flight response. This will be important also for A level when we learn about things like conditioning and how phobias are formed and things like that. But for now, we just need to know that the amygdala is associated with memories that are of a negatively balanced emotion usually, but not always. All right, the aims of the study or the key questions are we're asking if highly emotional experiences are more memorable than those that are not highly emotional, and does activation of the amygdala have a relationship with memory? Is it a predictor for how well we're going to remember something later on? All right, the apparatus of the study is a functional magnetic resonance imaging scan. Um, People do some weird things in fMRIs. I shouldn't show this image. I'm sure somebody on a test will write that they played the piano or keyboard while in the fMRI. I'm just showing this image just to let you know that MRIs and fMRIs are not just used for like car accidents or trauma or things like that. They're also used just to study which parts of our brain become active during certain complex or simple tasks. So here is an example. All right, to get a little bit more into detail about the MRI and how it was set up, we have a projector, a rear projected image that was shot onto a mirror, and the participant, in this case a healthy female who was right-handed, would stare at this image. Why was she right-handed? We'll talk about that perhaps a little bit later. But essentially, it's a unnatural experience for most people, but fMRIs are things that we use every day in hospitals, so it's not too unnatural of an experience, but most people have not experienced this, especially as they look at images. So what were the images? The images were the International Effective Picture System. These are these pre-rated or normatively rated images that have been already rated for two things: how intense the arousal is, and what valence they have. The word valence, you may have heard it in chemistry, has to do with the degree of negativity or positivity that an item has. So, for example, the first image is a old chipped coffee cup. This is a neutral image in all likelihood. I think most people will find this image neutral. I might find it positive because I love coffee, but some of it's subjective. Baby being happy is for most people positive. Again, subjective. Maybe for me, I avoid children because they touch your stuff and break them. But most people would say that's a positive image. Skulls in a catacomb, maybe that's negative, probably negative. So we just practiced putting things on a chart of arousal, and with the 96 images that the IAPS uses, they make sure to have images that are scattered all over this chart. Okay, so the y-axis represents how emotionally arousing the images, and the word arousing could be positive or negative, just exciting. Um, and the valence is, again, like we said, the degree of positivity or negativity of an item. So here, if we look at an image of a man painting a wall yellow, we're probably not that piqued by this. I mean, some people, again, this is subjective, might find him attractive, but I think for most of us, we could put that somewhere safely in the middle in terms of valence, and for arousal, we'll put that somewhere low. All right, so this is a neutral image that doesn't arouse very much. Whereas if we look at an image of kittens, this might be slightly more arousing, and this will fall more into the positive realm. Again, subjective. Some people hate kittens. I don't understand those people, but there are people out there who hate kittens. Bungee jumping, woman smiling. Of course, we're going to have high arousal, and we're going to put it positive. Okay, again, high arousal, negative. Now, this image may be disturbing, but in order to elicit strong responses in the amygdala or in general in the self-reports, we want to make sure we have images that could be somewhat disturbing. So, some students in class may feel like, oh, you can't show this in class. Well, this is part of the apparatus. I mean, this level of violence is actually present or in the IAPS, or similar levels of violence. Okay, going back to something that's more neutral. Okay, so I hope you get the idea that, again, these things were pre-rated on two axes, the y-axis being arousal and the x-axis being valence. So as we watch these images, we're looking for two possible fMRI results. We're looking for either no activation or a baseline of some sort, and we're looking for, of course, amygdala activation. And we will quantify this. This is quantitative data, not qualitative, because you could actually count the number of pixels or voxels that these images or 3D images have. All right, so I gave students a ranking task. I gave them pictures from the real IAPS. They're low resolution pictures. The reason for that is that you have to pay for the IAPS or get a grant from the people who created it, because these are things that have been strongly validated, and they're quite reliable as being across a spectrum of arousals and valence. They already have predetermined normative ratings. All right. So, for example, the Hershey bar might have a normative rating of like 2.6, and then we compare that with what the people in the study actually do to make sure that this measuring device or this apparatus is in conjunction with the feelings of the participants. All right, so the participants themselves were, again, 10 right-handed healthy female volunteers. We don't know if they were paid. We don't know how they were recruited. The study just gives us this one sentence. So if you ever ask a question about the participants, don't feel pressured to know their economic status, their racial status, because we don't have that information. But what's interesting is that they were chosen because they're more likely to report intense emotional experiences. This might be like a social stereotype, but they wanted to avoid men because women were more open about their experiences. I think there might be a self-generating stereotype about men where they don't want to report having a high emotional reaction because they're too tough. Oh, I've seen dead bodies before. I've seen men on fire before. So again, women were more open about sharing their level of arousal. All right. So the procedure is, again, the FMRI or the MRI imaging machine, and then 3 weeks later, you ask them questions. So while they're in the machine, they're pushing a button on a keypad in their hand, 0, 1, 2, 3. If the image is tranquil, it's 0. If it's somewhat tranquil, it's 1. If it's arousing, it's 2. If it's very arousing, it's 3. All right, so you could break it down into two halves, the first half being tranquil, the second half being arousing. Then 3 weeks later, they didn't realize this. They were surprised to get a sort of like a memory test. And the original 96 images were intermixed with 48 foils. What is a foil? A foil is there to be a decoy or be some sort of wrong or image that wasn't used originally. So it's a comparison point. So just to keep things honest, just to keep things, keep them guessing, they would purposely stick images in there that were not from the original study. And of course, they would ask, do you remember this? The answer would be yes or no. Now, that seems easy. That seems like easy data to quantify. However, if they said yes, they had to say if they were confident or somewhat confident. So it was broken down into three categories. The three categories were, excuse me, I'm sorry, I'm jumping here. The three categories were familiar, stop, all right, familiar, which was somewhat confident, and remembered, which was absolutely confident. And of course, if they said no, it's forgotten. So let me do that one more time. So if you said yes, and it's very yes, it's remembered. If you said yes, somewhat, it's familiar. If you said no, it's forgotten. That's how they operationalized the degrees of memory. Okay. So what type of memory? I'm kind of jumping out of order. I should have done this earlier, but just so you know that we're actually looking at what's called declarative memory. They're not testing procedural memory here. Declarative memory is the memory of facts and events, or semantic things, or recognizing things. So, for example, if I recognize that actor as George Clooney, that's more of a declarative memory. If I am riding a bicycle, that's more procedural memory. So we're just dealing with one type of memory. And now typically memory is associated with the hippocampus. Um, Declarative memory is associated with the hippocampus. Why is this important? Well, the amygdala is right at the tail end of that hippocampus. So, it just was thought that this one area was in isolation, but now we're discovering that with the help of studies like this, that it goes farther further, than just the hippocampus. So we had some fun, testing our declarative memory with some logos and things like that. You could pause this if you want to play again. All right, there's some SAT words. But let's get to the good stuff. 2 weeks later, we actually had our own attempt to replicate the study. Now, I say 2 weeks. In the study, it was 3 weeks. We didn't have the luxury of time because we had Thanksgiving break to do 3 weeks. That would have been too long, because we have to get to the next study next week. So that being said, we tried to replicate the study as best as possible using various images that you rated and gave a number to, and if you remembered them or not. And what's really interesting about this is that the data that we collected for our own study was somewhat similar in terms of which is highest, which is middle, which is lowest. So if you look at the original study on the left here, of course those that are rated 0, most of them were forgotten. And then for some reason, the remembered is second highest and the familiar is third highest. Now that seems counterintuitive a little bit, but what's surprising is that we have similar results in our attempt to replicate the study. And of course, with the last one, there's a difference in that you guys mostly remember the traumatic images, and I made sure to use images that were of a similar resolution and you had similar exposure to, so it wasn't like a biased, it wasn't biased data. That being said, though, why did that happen? Well, there's several reasons. I'm sure one of them is that we only had 2 weeks instead of 3 weeks like the original study. All right. Let's talk about application of the study. I find that students sometimes struggle with application. I know in the last test, many students got the application wrong at half or no credit. Try to think of an application whenever possible outside of the realm of psychology, if possible, and not to give general statements like, this is useful for people. Try to give a profession. So for example, if we were talking about Milgram with the shock study, we would say these findings can be useful to historians when trying to understand the causes of genocide. Again, Pilyavin can be useful to bystanders when trying to help in a public situation. Or Demetclamin can be useful for sleep scientists when trying to discover when their patients are dreaming. Something like that. So what is the application of the Canli study? I think this is one of the best studies for a modern application. This study is very new. It's from the year 2000. This study came out after I got my psychology degree. And you could easily say that this is useful because advertisers could take advantage of this science to try to manipulate advertisements or create more memorable advertisements. So how do you do that? Well, according to this article from 2007, many consumer neuroscientists were on board with this type of research when they created very expensive advertisements for the Super Bowl. And I remember the Super Bowl advertisements cost like $1 million a second or something like this. So you want to make sure you make the most of that and have a memorable ad. So we watched some Super Bowl ads and we talked about how more and more adverts, whether it's for something that's tranquil or not, are trying to ramp up people's amygdala. They're trying to ramp up their arousal. All right, let's skip these commercials. Okay, Anyway. All right, skip that. All right, so we did some revision, describe the initial procedure of the study. Remember that the initial procedure is at the first week, and then 3 weeks later they have to see if they remembered what they saw. So the 96 images, keep in mind, were randomized. Why was this done? This was done to prevent order effects, things like the fatigue effect. You want to make sure that different participants have different orders, so that if the image is of someone throwing a smoke bomb for the first trial, that maybe for the next person it's for the 30th or the 40th or the 96th trial. Okay, so you're constantly randomizing these images. Now this sort of acts, we didn't talk about this directly in the video yet. You guys have the index cards with this. Keep in mind that there are several controls. They have to look at a fixation cross. Okay, this is a cross on a black screen to make sure they're looking in the same direction when the image starts. Okay, this is sort of acting as a control. Another thing that we never talked about, at least not in this video yet, was that there was 2.88 seconds per image and 12.96 per interval. Why not 3 and why not 13? I don't know. I think they just want to make us sweat to memorize this stuff. But in an essay or in a response, if you said approximately 3 seconds per image and 13 seconds per interval, I don't see why that would be a problem. Anyway, why is this important? It's important because it's acting, again, as a control. Also, the 13 seconds is important because it's giving the participant time to react with the keyboard and also to bring his arousal level back to a baseline. And we'll talk about baselines in just a moment. All right, so here we have a larger version of what we looked at just a few moments ago in terms of the percentage remembered of each category of arousal. So tranquil being 0 and highly arousal being 3. Just like with Schachter and Singer, I'm not going to ask you to remember specific numbers. I'm going to ask you to remember comparisons. So, for example, knowing that more people remembered in the highly arousing situation as opposed to the lowly arousing situation. I think those kind of comparison points for the short-term goals are good enough. As we get closer to the exam in May, maybe some of you want to know some numbers, but I don't think that way. I don't like memorizing numbers. I like knowing more about the overall results first. Also keep in mind that this is quantitative data, but so is this. All right, we talked about this just a moment ago, where the pixel count for the brains was also quantitative. Now, here it says there was a measure of the voxel count. I've seen in the textbook they mention pixel counts, so I would just put pixel/voxel if they ever ask you about how the activation was quantified. All right. Now, there were both MRIs and FMRIs used. So the MRI is a structural scan, and the FMRI is more of a functional scan, of course. And the reason why they do both is so they could superimpose the FMRI over the MRI to make sure that the part that's lighting up corresponds with the structural piece that they're looking at. So in this case, the amygdala. Now, here's where it gets really confusing, and I hope to break this down more simply. In the primary source, it tells us that 11 frames were captured per trial with the fMRI. Okay, so remember, the MRI is a static image, so it's 8 slices, and for the fMRI, it's not static, it's moving, so it's frames. So it's like an animation. During the fMRI, these 11 frames were captured, and the first 2 frames are baseline, and the last 2 frames are baseline. What does that mean? Well, if you look at this graph, it kind of explains it. So the first frame, no image. The second frame, no image yet. All right, but then we get to the next frames, and then we have the 3 seconds of the stimulus presentation, which in this case is the IAPS photograph. All right, then the person would have a reaction, and then you would give them 13 seconds to get back to baseline. So you see here, we start off in the middle somewhere. We, in the case of the green line, which is the highly arousing line, we spike up. Even after the picture, we're still spiking because we're still reacting to the picture. And then we come back down. All right, this is to make sure that the next image is also starting at baseline. We don't want to have the images go too quickly together. We want to make sure there's like a recovery period between each image. Okay, I use the analogy of wine tasting. You take a sip of wine and then you put some water in your mouth to cleanse your palate. Okay, so same thing here. We have to cleanse our mental palate, if you will. And please, I'm trying to make this video quick, so if you want to stop at any of the images, please pause them. All right, more data. Just to let you know that there was a check to make sure that the people's ratings of the pictures were within the ballpark of the pre-established or normative ratings for each image, and using what's called the correlational coefficient, which is on a scale of -1 to 1. There was high correlation between the participants' judgments of the pictures and those numbers that were already assigned to those pictures. So remember, each picture already has a number assigned to it. Okay, let's skip this stuff here. All right, so what are the conclusions of the study? It's pretty much everything we were looking for happened, but a lot of the stuff is correlational. Amygdala activation is a good predictor for subsequent memory. So in other words, if we see something that's highly arousing, it's likely we're going to remember it later. Okay, and we are more likely to remember emotionally intense images. So there is a biological element, which is amygdala activation is a good predictor, and there's more of a general psych element, which is we are more likely to remember things that are intense, emotionally intense. There's the same thing I just said in the primary source. All right, let's evaluate the study. Here are some examples of questions that could be asked on an assessment, maybe tomorrow's assessment, hint, hint, hint. All right. I'm rather lazy. I like to cut and paste things that have already been done. So, if you want to take some time and think about these questions, please go ahead and do so. But we just quickly went through the rest of GRAVE. We already talked about application being high. Generalizability is somewhat low because there are only 10 people, which is because it's an FMRI, which is time-consuming and expensive. But even though they're right-handed females, we could still say, well, hey, everybody has intense emotional reactions, or most people do, and everyone has an amygdala. So when it comes to biological things, whether it's REM sleeping or this, we could not make generalizability too low because it is biological. Reliability is super high, right? Because of the fMRI machine. The thing is super reliable. It's a computer. So computers they build their reputations on being reliable. Also, all the controls that are in the study. The participants have to have a bite bar so their head doesn't move. They have to look at the fixation cross. The IAPS images are always the same, the 96 images. What else is a control? They're all right-handed females, so it's always going to be the left amygdala that we're looking at, okay? And just to make sure, I didn't mention this in the video yet, but we talked about this in class. They're right-handed women because you want to make sure that you're looking at the dominant amygdala, okay? Remember, the left side of the brain is associated with your handedness. So if you're right-handed, you're probably left dominant. Not always, but usually true. Application is high because there's lots of money to be made in advertising. Validity is somewhat low because it's a lab study and we don't go to fMRIs every day and we're not asked to look at pictures. But I'm going to put it somewhere more towards the middle because we do look at intense images on a regular basis. It's called television. It's called HBO. HBO makes its living off of intense images. So, even though it's in a fMRI, it's not super low in validity. Also, the images were validated as being accurate to their arousal ratings. And when it comes to ethics, it's somewhat high, but the problem is, again, we're showing some violent, in some cases, terrible images to people. And so there might be a potential for harm. And it could be longer-term harm than we know because, remember, these images were remembered after 3 weeks. So they weren't leaving the laboratory on the first initial trial or the initial procedure and forgetting these things. They actually had these images stick with them. So in some case, there might be some issue of protection from harm, psychological harm. All right. I know I went through that very, very quickly, but I wanted to get something up here before tomorrow. And feel free to leave a comment, or if I omitted anything that was significant, please put it in the boxes below on the YouTube channel. and give a thumb in any direction that you feel fit. And I'll see you guys later. Bye.